Welcome to Geometry. This is section 1.1, Points, Lines, and Planes. This is Mr. Godino, and today we're going to talk about some of the basic vocabulary that geometry is built on. So our learning goal for this section is to define and identify the basic geometric terms and distinguish the similarities and differences between them. We'll achieve this by, again, defining these terms. Then we're going to learn how to name these geometric figures and terms, and finally how to represent them visually. And today's lesson is going to be a little bit different. It will focus mainly on vocabulary, but I will be showing you some diagrams to help visualizing the terms that we're going to learn. So before we get started, I do recommend that you take good notes on this vocabulary, as we'll be using it all throughout this whole chapter. And a good way to do that is to make a graphic organizer similar to what you see on screen that has 3 columns, and on the left side we're going to write some definitions and characteristics about the term. In the middle we'll have a little diagram or drawing of what we're talking about, and on the right side we will discuss how to name these figures. So let's go ahead and get started. As you can see, our first term is a point. Now, under a definition, we have it's a location in space that has no dimension and has no size. This point is the basis of a lot of the other concepts we're going to be seeing, but the way we represent it is just a dot. Now, anytime we have a point, I want to be able to reference this point. And so to put a name on it, we use capital letters in geometry. So we could, for example, name this point we have point A. And now if I wanted to go ahead and draw a second point, I could call this one point B, or whatever capital letter I choose. Now the benefits of having these names assigned to the points is that if I tell you to go ahead and circle point B, you would know exactly which one I'm talking about. So our next term is a line. Now a line just is a figure that extends infinitely in both directions and thus has arrows on each end to represent that it keeps going. So it might look something like this. Now, there's a couple very important characteristics that we need to understand. First of all, a line has no thickness. So even though the line keeps growing infinitely in the direction in which the arrows are pointing, it doesn't have any thickness, and for this reason we say that a line is one-dimensional. Another important characteristic about lines are that they contain infinitely many points. So what this means is that within this line that we drew, you could locate as many points as you'd like laying on that line, and like we saw before, we could also put a name to each one of these points. Now, for when we want to name a line, there's actually a couple different ways to do this. The first one is if we know some of the points on the line, as we can see on our diagram, we can choose 2 of those points. I'll choose, for example, points A and point B, and then we just have to draw the little line symbol over those 2 with its end arrows to represent line AB. So that is one way that we can name this line that we drew. But like I said, you can choose any 2 points that are on it, and since B and C are also on that line, I could have also chose to call it line BC or potentially line CD, as long as the points are on that line. Now, like I said, there's a couple different ways to name lines. Another scenario is sometimes your diagram will contain a small lowercase letter near one of the arrows, and if that's the case, we can simply refer to that line with that lowercase letter. So in this case, we could also call this line line M. So to summarize, you can name a line using any of the points that lay on it, or using a lowercase letter. So our next term is a plane. Now a plane is just a flat surface that extends infinitely in all directions. Now when we look at what its diagram looks like, you'll usually see a figure like this. But that can be a little bit misleading because it looks like that figure has edges and that it is a finite size, where in reality, like I said, planes are infinitely large and they never stop in any direction. And there is a couple important characteristics we need to understand about planes. Similar to lines, planes have no thickness. However, unlike lines, planes are two-dimensional figures because you can travel forward or you can travel side to side on a plane. And another important characteristic about planes is that they contain infinitely many lines or infinitely many points within them. Now, as you can see on the right side, the way we're going to name planes is by using any 3 points that are on our plane that are not all in a straight line. So, for example, if I have points A, B, and C, notice they are not all in a straight line, and so I could now call this plane ABC. Likewise, I could have also called it plane CBA or BCA, whichever 3 points, as long as these 3 points that you're choosing are clearly on your plane and they are not collinear. And similar to lines, sometimes there's another way that you can name planes. So sometimes you're giving a cursive letter next to one of the corners of the diagram, and if you are given that piece of information, you can just then refer to this same plane as plane R. But again, this is only when you are given that letter. Otherwise, you're going to choose 3 points on the plane that are not in a straight line to name your plane. So now that we've seen and learned about points, lines, and planes, which are our fundamental undefined terms in geometry, we need to look at a few more important terms for this chapter. And so we're going to look at line segment. Line segments are often confused with lines, but visually they are different because line segments do not have arrows on the ends. And so as opposed to lines, line segments have a finite length. You could actually measure the length of a line segment. And it's often helpful to think of line segments as just a part of a line between two endpoints. So here, if we wanted, we could call the endpoints S and T. And the notation we're going to use to reference a line segment is similar to what we did with lines, but now I'm going to choose the 2 points that are our endpoints, S and T, and over those I'm just going to use the line segment symbol above those 2 letters. Notice the symbol does not have the arrows because we are not talking about a line segment as opposed to a line. And it's also important to notice that just like with lines, a line segment contains infinitely many points. So for example, I could have point A and point B here. And now that if you think about this critically, we've actually created a wide variety of different segments here. So in this diagram, I also have segment AB. I could do segment BT. Segment AT is also a different one there. And as you can see, some of these segments overlap with each other, and that is perfectly fine. The next term we're going to talk about is array. A ray is a part of a line that starts with one endpoint and stretches infinitely on one direction. So for our diagram, we can draw a figure something like this, where on one end it does have an endpoint, which we can call maybe point A, and on the other end, however, it's going to have an arrow representing that it keeps going on forever. And just like before, our ray can contain as many points as you can imagine, so why don't we go ahead and put point B here. Now, when you're going to name rays, you got to be careful with the order in which you place your capital letters representing the points. You will always start with your endpoint, so in this case A, and then some other point that's on that ray, for example B. And our ray symbol has just one arrow, but it is always an arrow pointing to the right. So we can now call this ray AB, and notice A is our endpoint because there is not an arrow on that side. So we just have a couple more terms, so we are almost done here. But the next thing I want to talk about is the term collinear. Now, when you have collinear points, that just means that the points lie all on the same line. Co means that they share something, linear means line, and so these points are all going to share one line. And again, we can call these points anything we want. And if I had another point over here that is W, then we would say W is not collinear with X, Y, and Z. And so then when you're naming collinear points, really all you have to do is just list out the points that are collinear. Our next term is midpoint. The midpoint is just the point that is in the exact middle of a line segment. So if we look at a quick example here, if our segment is AB, notice it has the endpoints A and B, the point that is exactly in the middle of this line segment, we would call it the midpoint. And often you will see that the capital letter M is used to denote the midpoint, but it does not necessarily have to be an M. Just like with any other point, you can choose any capital letter. So the last term we're going to look at in this section is a segment bisector. A segment bisector is any geometric figure, like a line, ray, or line segment, that cuts another line segment into two equal parts. For example, I could have segment AB being bisected by ray XY. What you have to make sure you understand is that this segment AB was cut directly in half, so this distance would be the same as this distance here. And for this example, I used a ray bisecting segment AB. However, you can also have segments bisecting segments, or you can have a line bisecting a segment. And if we want to think about how to name this, we simply have to provide a description. So here we have ray XY bisecting segment AB. So that covers most of the key terms that we need for this section. So here are your high-level questions. How are lines and line segments alike, and how are they different? And can you think of real-life examples of line segments and rays?